Minasan konnichiwa. Watashi wa Greg desu. Yoroshiku onegaishimasu. Arigato. I'm here to talk to you today about OpenTelemetry, what's going on with the project in 2025. We have some of the latest milestones and what's next. I only have 5 minutes, and I'm going to talk about 4 things, so I may speak a little quickly. I apologize. But I want to get you knowledge of what OpenTelemetry is, why it's important, why it's something you should care about, talk about some of the recent innovation we've seen in OpenTelemetry about profiling, talk about what's next, which includes entities and support for CI/CD, and then how to learn more, how to start using OpenTelemetry. So what is OpenTelemetry? This is a definition from the project website. I will read it, I guess. OpenTelemetry is a collection of tools, APIs, and SDKs used to instrument, generate, collect, and export telemetry data, which is metrics, logs, traces, and more, that helps you analyze your software's performance and behavior. It's a very complicated definition, especially if English is not your native language. So the shorter version is, OTel makes robust, portable telemetry a built-in feature of cloud-native software. And it's sort of the plumbing that connects your applications to your observability system. So what's one of the recent innovations? The biggest recent innovation in OpenTelemetry is profiling. And this is support for profiling frames as another native data type. When most people talk about observability, they say, oh, metrics, traces, and logs. Some people add events. Now you should also add profiles, because profiling is a native data type now in OpenTelemetry. The reason why you care about profiling is to investigate CPU, memory utilization of code while that code is running, and to be able to identify problems in your code down to like the line of the source file. And this is unique in OpenTelemetry because this data is being correlated with other data that you already have. So if you see like a CPU spike metric, you can say, oh, let me go directly to the code that caused that. Why is the CPU consumption higher? Right? If you're finding problems with traces that you see between these different microservices, there's some sort of a problem, again, you can go directly to the code that is calling that other service, like why are we calling it, what's doing that? And then in logs, probably the most powerful application of profiling is using logs to find out why a log line got omitted or didn't get omitted, right? Sometimes in the log line, you'll just see like error, and that's not super helpful, right? With profiling, you can go see the error, you can go see what method was called, you can see where in the source it was called and figure out, hopefully, why it was broken. Some of the recent news about profiling is that Elastic donated an eBPF-powered profiling agent to CNCF. I work at Splunk. Splunk's also donated a .NET profiling agent. There's more coming for other languages as well. So it's a really exciting time to be involved in the project, because it's really letting you troubleshoot problems quickly. So if you aren't familiar with what profiling does, this is one use case for profiling. And what you'll see is on the left-hand side, you can see that there's some functions that are being called and how long they're running based on that self-time. On the right-hand side, you have what's called a flame graph. This is not a very threaded app. If it was multi-threaded, you would see multiple columns. And what you can do is you can look at the bottom of this flame graph and read up to find where problems are happening and where things are being called. Right? So you'll see we select this long-running thing. We scroll down to the bottom. We see that there's a random call that's being made. That's not in our code, right? Those are from the Java SDK, the standard library. But then you do see where our code is calling that. You see the name of the function, you see the file that it's in, you see what line that it's on. And so being able to directly jump to, hey, this is where the problem is why profiling is important. So 2 things that are coming. One is entities. Entities represent other objects that are associated with telemetry, but really aren't telemetry data themselves. So these are things like what service emitted a metric, what host was it running on, what was the process name or process ID, what was the name of the container. And these help you figure out where data is coming from. And over time, tools will let you filter your view based on these entities and let you see, like, is there something in common with all of these problems? Are they coming from one host or one container or something like that? And the OTel project's big on standardization, making everything the same across, and so this is one of the things that we'll be doing. Also, CI/CD support is here. Semantic conventions for CI/CD landed in version 1.27. This lets you collect that CI/CD data consistently, and it lets you tie code changes to other performance data, right? And you can use that to automate decisions like promotion to canary or rolling back. So, 4 minutes, you want to learn about how to do more? Please do more. Please join us. The project website is OpenTelemetry.io. If you'd like to experiment and get started, there is the Astronomy Shop demo that's linked here on the slide. We are also in the CNCF Slack in OpenTelemetry. And at Splunk, we did make a game about OTel. If you'd like a gentle introduction, pipelinepursuit.splunkgames.com. Thank you all very much for your time. Arigatou gozaimasu.